factoring, super important. You did it in Algebra 1, but that was years ago. So we're going to factor each polynomial by taking out the greatest common factor. The greatest common factor is the largest thing that goes into all of the terms. And you should always look for a greatest common factor first, even when we get to more complicated problems. So looking at 4x squared and 3x, if you look at the numbers in front, we have 4 and 3. The largest thing that goes into 4 and 3 is 1. But we're not going to factor out a 1. I mean, we could. Okay, we'll leave it there for now. But we also have to look at the variables. They both have x. This first one has x squared. The second one has x to the first. We have to go with what they both have. And they both have at least x to the first power. Now, you're not going to write 1x to the first as the greatest common factor. You would just change that to x. And when you factor out a greatest common factor, it's kind of like the opposite of distribution. So we're filling in the blanks. We're saying x times what would give us 4x to the second power. And x times 4 would give us 4x, but we need another x. So 4x. So x times 4x gives you the 4x squared. That part is handled. Minus x times what would give us 3x. That would be 3. What's left inside the parentheses should never have any common factors except for 1. If it does, you didn't take out the greatest common factor. You're also going to want to make sure that you put these in standard form. Standard form means you have your highest exponents first on the variables. So if you look, we have 10y to the third, then 10y to the second, and 5y to the first. That's the order you want them. So looking at the numbers 10, 20, and 5, the largest thing that goes into those is 5. Do they all have a y? You bet your face they do. They all have at least y to the first power. So that would be our greatest common factor. And now we're filling in our blanks. We're saying 5y times something would give us 10y to the third. So 5 times 2 is 10. We have y to the first. We need y to the third, so we need 2 more y's. So we'll put 2y squared. Again, if you multiply those, you need to get 10y to the third. So for the next term, we're looking for 20y squared. 5 times 4 is 20. Y times y gives you y squared. And then the last term, 5 times 1 is 5. Well, in this case, negative 1. And then we already have the y. So that would be in final factored form. Again, if you want to check it, you can distribute that 5y to all the terms and make sure that it comes out to the original problem. That's actually not a bad idea, Mr. Plant. Not a bad idea at all. If you look at C, this isn't in standard form, so we need to reorder it. The higher exponent should be in the front, so we'll move the negative 8x squared to the front and the negative 12x to the back. Now, anytime your first term is negative, we're going to factor out a negative sign. So think of 4, well, oops, it's 4, right? 4 is the largest thing that goes into 8 and 12. So we're going to kick out a negative 4. They both have an x, so we're taking out negative 4x. That's the greatest common factor. Negative 4 times positive 2 gives us the negative 8. We have x, but we need x squared, so we need another x. Now, this is the tough part, because negative 4, if we're looking to multiply to negative 12, negative 4 times positive 3 would give us that negative 12. We already have the x out here, so that would be it. Again, if you distribute that negative 4x to both of those terms, you'll end up with negative 8x squared minus 12x. Let's do one more. Their greatest common factor is 1. And when their only common factor is 1, you don't do anything else. This is non-factorable. Not factorable. And that's pretty rare. They're just trying to goof with us a little bit. So I'd like you guys to pause